Hello everyone, welcome to this stream. Today we will continue work on the Glasgow Digital Interface Explorer. So let me show you what it is and remind you what we were working on. So this is Glasgow. Glasgow is this smallish device. Maybe this orientation is the correct one. So it is a USB to N interface. So many people on a regular basis ask why is it called Glasgow? Glasgow because FTDI, the company making the interface chip, they have their headquarters in Glasgow. So that's why. So this started out as a replacement for FTDI, but it got a little bit more featureful and expanded beyond what FTDI can do. So this actually is, the hardware itself is comprised of an FX2 Cypress USB interface chip and an ICE40 HX8K FPGA. And then it also has level shifters for 16 pins in 2 banks of 8 that have dedicated voltage regulators for level shifting. So you can set what I/O voltage these pins are driving as well as receiving. And it has ADC so that you can measure the voltage. So they are on separate pins. You have voltage here, the settable voltage output, and you have a sense pin, so you can sense the output. And it has dedicated chips that can set a pull-up or pull-down resistor on each of the pins. So usually you would have that in a chip that would have bare pins that you can set pull-ups and pull-downs. So these 16 pins are very flexible. And each one of them can be set as an input and output. So another thing that is a little bit different from other devices is that the pins are not grouped together that can be input or output. Each one can be individually set as an input or output. That's why we have all the single level shifters. I wish that a chip existed that had dedicated single pin input-output settings and level shifting in one chip, but unfortunately that doesn't exist, so we have to use discrete level shifters. And we have, as an auxiliary interface, we have Lvds, so low voltage differential signal. So there are multiple differential pairs on here, and all that goes into this FPGA and is connected to the computer over USB, high-speed USB. And the magic of the whole system is that you have a software on the computer which synthesizes the FPGA bit stream on the fly depending on the application you're using. So you want an I2C interface, so it instantiates an I2C interface block, synthesizes it on the fly, loads it onto the FPGA, and you have hardware support for I2C. But in theory, you could say, well, but then I can take a microcontroller. They already have the hardware for I2C, so why bother? The nice thing here is that you can set it on every pin. In theory, you can instantiate more than one. You can have 10 I2C interfaces, or you can have interfaces that don't really have hardware support on modern chips or modern interfaces. So for example, you want to talk to an old floppy disk drive that has a very weird protocol, but you want to talk to it at full speed, and you want to have it in hardware reliably, then you can instantiate and build your own hardware implementation of that protocol and put it on here and talk to it directly. So the alternative approach would be to have a logic analyzer to at least read the data in and then analyze it, have a decoder and on your computer, like in Seagrok, for example. Then you can ingest it and read it in. But then you are limited by the sampling rate of your logic analyzer. Doing that in hardware gives you the advantage that you can not only read in and decode it in hardware, but also write it. And so you have a bidirectional interface. And it opens up a huge field of opportunities and possibilities to talk to different hardware with a hardware implementation of different protocols. So this is a very unique tool and only enabled by the open source FPGA toolchain, because part of the software stack is the FPGA toolchain. This is not really a thing you can expect from a commercial tool that requires a vendor toolchain and a license, and you have like a 80 gigabyte installation of Vivado, for example, that you would have to carry with you. Here it is, the open tools are much smaller, so you can actually expect it to be part of the software stack that is used for a specific purpose. So this is very unique, and I think this will be very interesting. So we are gearing up for the campaign since quite a while now, and today I will continue work on the PCB layout. We had some changes we wanted to do, so let me show you the to-do list. So this is the current design of the board, and I made a to-do list, and I crossed up a few things between the last stream. So this is episode 4. Oh, I should have changed the topic of the stream. I am very sorry. It's stream info. So let me change that really quick. And I think this is also 4, but it is Glasgow KiCad design. Today we all right, so that should be updated now. Okay, so yeah, sorry about that. I should have I should have updated this before the stream, before the emails went out to people. But yeah, so this is the status. We had to swap the resistors to 4 pins because of availability. The 8-gang resistors are not very common. Then we wanted to swap the level shifters to easier to solder. So that's an interesting side note here. So this chip, this SOT 363, I think I replaced it with a different one. But what we had before, right, so we switched it to 363. But before that, we had the SOT 666, I think, or 333. I'm not exactly sure, but they were. I had a bad experience with having more shorts on them with reflow and stuff like that. And now I was assembling, and this experience comes from the Blackmagic Probe. So the Blackmagic Probe, if you look here, is actually using these footprints. If I show you, so this footprint here is already, so this is that, and this used to cause issues. Even so, I was using the one that is in the KiCad library, and that one had a lot of shorts. This footprint improved the situation because it was created a bigger gap between pins and was wicking away more of the solder on the center pad. So it helped with that issue. But I still had issues with shorts. And I was assembling Blackmagic probes this last week, and I didn't have any issues with them. So I have multiple of them. So if you see here, there are also MOSFETs that are on this footprint and another MOSFET on this. And none of them had short issues. The solution was to use a PCB vendor that does a good job. So it turns out that the boards that I was using before, they were from PCBWay, and then I think mostly PCBWay. And they had still the issues. And now I have boards from KiCad, and besides the board quality in general being better, which is very nice, it actually resolved the issue with the soldering. I don't have shorts anymore. So it did really help that you using a PCB vendor that is doing a better quality PCB. So these PCBs are on par price-wise to PCBWay, but they are doing a better job. So I never like recommended a Chinese PCB manufacturing house before, and yeah, and KiCad, which is this company here. Let me see. Yeah, so let's open that. So this is KiCad. Yeah, and they are doing a good job. The quality of the boards is much better. They might not be, they are not as cheap as some others, but the quality of the boards, they impressed me actually, because I had really weird requirements for one project. I wanted some really weird stuff on the board. And I sent them an email because they got recommended to me by Bunny and Zobs, so Sean Cross. They are using them for FOMUS and other different projects. And it's just the tolerances are much tighter, and it's like the solder mask is the registration is better, the pads are tighter, everything is, the tolerances are all tighter. So to answer Timon's question, and it is all overall a cleaner board. And so I don't have some of the boards from PCBWay, the solder mask was chipped away, fallen apart, not there, or the pads were bigger and they were making changes to fit their mass production line. They were not trying to actually build the board I asked them to. They were just adapting my board to their process. That's basically what my experience with Chinese vendors was a lot. KiCad actually is trying to match what you requested them to do. And this is what I was getting with that story too. I sent them a requirement, and without having to ask twice, they were basically came back to me with prototypes and photos of like made the board with my specs, and were like, well, that doesn't really work what you are asking. It's like, this is like falling apart the way you want. We could try these things. And I'm like, okay, let's try these things. Then they tried again, and they tried again, and they tried again to get what I wanted. And then we converged on something that was workable technically, and they were able to do, and I was happy with. I have never had such an experience, and they didn't even charge me extra for this. They actually like put like effort into trying to do what I wanted. So the service was great, and that's since then I started to recommend KiCad to people because they impressed me. They really, that I have not seen that from another vendor. It's like I've seen it from one or two US vendors, but they usually also frown upon anything out of standard because they just want to make as much money as possible and crank through it. So I'm not sure I would. So the only place that I can recommend here in the US is for prototypes, Oshpark. They are awesome. The quality is great for prototypes. So just keep going with Oshpark for prototypes. They're wonderful. But KiCad really impressed me here. So they definitely won a lot of my business this way. Yeah, and they're for a bigger quantity for sure. Yeah, so in general, also it's like making a blanket statement about Chinese vendors is a very bad idea. It's like they're also making iPhones, so they can make really high quality stuff. It just depends on who you talk to, which vendor you find, and how you set up your operation. So just taking that out of the way, the PCB vendors that I used so far, I didn't have a great experience with, unless it is like, well, whatever. It's like I have to compensate for the quality that I'm getting because I'm not willing to pay the price or fly over there and figure it out. And so, like that's the complexity here. You can fly over there and like get whatever you want, but it's. Is the Twitch stream title wrong? Possible. Anyways, so let's get back to if it is still saying SNES, then it is wrong. I did correct it to the Glasgow PCB layout, so we are getting back to the PCB layout. And so let's finish up the to-do list. So I wanted to mention that footprint thing. So I did sort that out. Essentially, if I get a good enough quality and it's like KiCad, that will be my solution for the boards. This shouldn't be an issue, but still, this footprint, so this is for the level shifters. So these guys here. So the level shifters used to use this other footprint. But it turns out I can get the level shifters at a lower cost in this package, which is the 363, I think. Yeah, the SOT 363, and thus we will stick to that footprint instead. Yes. Timon, that's exactly right. So finding the right vendor is the hard part. That's why I'm sharing the info with you, so that maybe my experience will be useful to someone. So the next thing we had locating pins for the Lvds connector. This is something I did yesterday. So I did find a Korean manufacturer of connectors that is making very nice connectors at a reasonable price. And this is their footprint. It is interesting how close the hole to the copper pad is. I'm not sure this will work this way, but I need to ask this. And there will be no keying on the Lvds connector itself. I was not able to source at a reasonable price something, but what it will have is keying on the back so that it will be located very accurately on the PCB. So if you put a shield or a daughterboard onto this connector, it will be not crooked on the pads, which can happen at this scale of a connector if you just place it and rely on the solder to pull it in place. Also, it is a little bit too heavy to be pulled in place, so we will be keying them. Yeah, no, there will be no prevention. So you have to be awake when you are plugging it in. Yeah, there will be not a keying shroud on the Lvds connector, unfortunately. So yeah, it relies on you thinking and being awake while you plug into the connector. That's it. These connectors are keyed and they will stay keyed. This is also the primary function, and they will have those blue keyed shrouded connectors. Yeah, it might be. That's a good question. I think the ground. So if you rotate it, I think it is not safe. So if you rotate it, you get 3.3 volts where ground is, and ground is where VIO aux is. So you will reverse voltage your target. So that's not great. PSPs and subtle trade-offs. Yeah. So let's see, Jared, what are you saying? So pick and place placement, cost per piece, and where the volume price breaks come, yield rate and pricing particular type of footprint. A complicated equation if you really want to dig deep into the trade-offs. Maybe someday I might be building enough of something to weigh all the factors. Yeah, feels like yeah, totally been there. It's a really, really, really deep rabbit hole to make all the trade-offs. So I might ask the vendor of these connectors if they can have a keying shroud. The problem is I don't really have space to have a full keying shroud on here, because it is butting up really closely to the other connector. So this will be a little bit of a limit. So if you look here, this is going really close to this other connector because of the mounting hole on the side. So the only option is to use this Samtec solution. So if you look here, so this is the Samtec connector that goes onto this footprint. Can I show you? Yeah, there we go. So you see this one has a keying shroud. The problem with that is this is Samtec, and so this is very expensive. It is a really, really nice connector. I love Samtec connectors. That's why Blackmagic Probe is getting them, because its primary function is this interface. And so I think it is important to have a really high quality JTAG connector on there. So I use Samtecs there. But for this board, as it is a secondary function and main interfaces here, I think the trade-off is worth saving like half the price, if not more, on this connector by not getting it from Samtec. And that also means we will not have the keying shroud unless someone, it's relative though. It's like in this kind of connectors, they are pretty common. So the Samtec connector is expensive, but not preventively expensive. So in theory, we could go for it, but I rather save those, I don't know, probably $30 in retail, so that we can put it to something else that makes more sense. So yeah, there also, so basically with the price difference, I think we might be able to include the mating connector with this board. So if you make your own daughter board for this, you can have a mating connector in the kit. So don't quote me on that. We might not do this, but the connectors definitely will be available. So this is something. So I will be carrying them in the 1BitSquared store. So you can get these large 22-pin connectors that mate with this in the store, and they will be very affordable. Yeah, in theory they could desolder it. I think this is a lot of trouble to go through, though. Yeah. Again, if you just are awake when you're doing things, it's like plugging things backwards in, especially on a big connector like that. It shouldn't be an issue. It is more of an issue with the interfaces that you plug in, plug out all the time. I do feel that in this particular case, it shouldn't be too much of an issue. Yeah, it is a nice to have that we will not go for in this case. For now, I will still ask them if they can make this limited shroud, but probably Samtec has a patent on it or something, so who knows. I doubt it. I seriously doubt that we will be able to do this. All right, so I did change that. I added this. I also changed the footprint to match the data sheet from the vendor. And I also replaced everything that didn't have round rect pads with, so essentially in the KiCad library, the librarians didn't update all the footprints, because I think they want to automate all the footprints and have them in scripts, and I don't have time for this. I spent 2 weeks updating just these footprints, so I submitted them upstream to KiCad. It took me essentially 2 weeks to submit it and get it in the library, and I'm not doing it for all the footprints. I don't have time for this. I need to get the Glasgow going. So essentially I copied them over from the KiCad library into the local Glasgow library and added the round rect and then imported it into the footprint. So essentially this will happen eventually. Maybe if I'm feeling bored, I will submit it upstream. But for now, we will have to live with this half-assed solution of having our own footprint copies. So Crystal was one of them, and the USB footprint. So that's that. What's next? Yeah, so round rect paths, move references to fab layer. So this is something we need to think about. I'm not 100% sure. I did already talk about this in the previous stream. I personally do not put references on the silk screen on my boards. I rather use that space for legends of what the objects are on the board. So basically described functionally what is on the board, because for repair and debugging, you have to, in like most of the cases, you have to open the design files anyways, and they are available. So you can just download them and open them in KiCad. That works on every platform, so it's not a problem. And so you would trace it on inside KiCad or use HTML bomb now that it has also tracing. So I don't it makes sense if you have hard copy printed out schematics and you are trying to find things on the PCB visually. I don't think this is really that necessary today anymore. So the silkscreen is very busy. It's full of this references. And except for the connectors that are actually outward facing, I don't think this is really necessary to have them on there. So I would love to remove them. I know some people might disagree with that opinion, but that's why I'm putting it out there for now, and try to convince me otherwise to keep them, but I think we will get rid of them. And use that space instead to basically describe these are pull-up resistors or pull resistors, and this is the pull-up, pull-down control. And then we have the DAC, and we have the ADC here, and then we have the settable VREG. Like, document what these sections do. I think that makes more sense, especially to communicate what the functionality of the board is. So that's why I think we should remove them from the silkscreen and only keep them and use it more as a documentation layer for the functionality. We already have the LEDs documented with which they are and what they do, so that's already cool. The Lvds connector already has a legend, and we still have to include who the manufacturer is of that board, so that's something. So yeah, this will make more space. For now, what I will do is just for footprint text back. There we go. So that looks much better already. So if we look at this, oh yeah, let's do that. Let's open the 3D rendering. So yeah, there's a lot of stuff on here that we could get rid of and make it easier to read the silkscreen. So yeah. What's next? So I am keeping that for later. which way did it go? This way. So let's move that for later. Remove the attack footprint. This is still a debatable thing if I want to keep it or not. Maybe I should just leave the footprint if it doesn't take too much space. Yeah, so yeah, Sylvain would agree with me. I was somewhat expecting that you would agree with me. But yeah, I still need a little bit more pondering probably. So we will. What another thing is, we usually what I use for. So there are two ways of doing placement and debugging of the board. Either you go with the HTML BOM. So if we do this, this should open it up eventually. There we go. So that took a little bit to render. So we have the signals. I'm really hoping that eventually, so you can find which part is which, and then you can also see which net is which. So you can see nets in HTML BOM, so you can highlight them and see. It's great for debugging. So we could even host it online somewhere to have that for people to look at. To mark pin 1, yeah, you can show that. You can highlight first pin, so you can do that. So you can highlight pin 1s, which is nice. I don't do that, it's making it yeah, the newest version also has the signal tracing, so that's you get the wires indicated. And the second approach is to have the hard copy that is basically just plotting, not plotting, it is in, I usually use the printer for this, and then print the some of the layers, including the fab layer. So on fab layer actually have the IDs, and the nice thing with fab layer legends is you can use the courtyards as the areas where a chip is. So just this front courtyard, this stuff that I'm blinking now. So these are courtyards, just basically as an outline of the part, and then put the IDs inside those courtyards. And then you know what value it is, because the values will go in there too, and what ID it is, so that you can reference it to the schematic. So you can really quickly geographically find stuff and use. So this is my approach, and this way you can use that surface area not only for legend, but also you can push things together tighter, and you are not running into issues where this solder silkscreen is requiring you to put stuff further apart. But in this case, we shouldn't be too concerned because we have plenty of space on this board. Okay, so all the tangents are now taken out of the way, hopefully. We can start looking into Joe9, thank you for your follow. Welcome to the stream. We should be able to route this. So there is one thing that I found, which I think so yeah, where are you? Yeah, Timon was making that argument last time. Timon will like this. So there are signal traces on the internal layer where the power lanes are. So yeah, you will like that. So yeah, there are places here that are so tight that I am personally also having a hard time to figure out how to route it without putting it on the power lane layer. So yes, I return. Wie heißt das? I return the honor or something? No, this is in Polish. That's something you say in Polish. Zwracam honor i przepraszam. So yeah, yeah. There's I am really curious if there's any way, and really doubt it by now, that it is possible to not have those signal traces on the inner layer here to actually route it around. So unless we go to a 6-layer board, which I don't think is really really worth it. Yeah, just go to 6 layers, right? Yeah, we could do that in theory, but I don't think this is really necessary for the few signals. This is the argument I think Timon was making. Essentially, if this is just like 2 or 3 traces, it's not really worth upping the layer count and just put it on here, even though it is like breaking rules in a way. But you save the price of upping the layer count to 6. So yeah, that's a fair point. All right, so the things that I can definitely finish routing here is do these. They shouldn't cause any issues. We still have, so the advantage of the 8-gang resistors was we could have 2 traces go on the inside here. This is not really possible. I'm sorry, possible here in this case, but let's do just this. So I can So we can definitely do these, and then we can worry about the hard parts of the layout in a minute. What are you? Huh. Where is that going to? Oh, it's going on the inner layer down to here. Wow. That's quite a run. Why is it going up here and then down though? That's the question. Yeah, we could theoretically... Oh, will it cut off something? Will it like choke some of the planes? It might choke a plane, a power plane here, if I do that. Let's see, who is connected to this here? So who is connected to here? Yeah, we might need to do some investigation. Oh, this is 3.3 volt. But this can go all around. Yeah, I think this one could just connect directly to this one, so we can do a shortcut here. Yeah. Yeah, Markan was the last person working on this layout, and he did a really good job in general. I'm really liking the layout of this board. So this is like things like this. This is very normal, where you work on a design and it's like you come with a fresh mind and you find more things to optimize. There's always never, the layout is never finished. It's only good enough. So so that's something to keep in mind here. Yeah. Why are we going? Oh, we are jumping this trace here. Interesting. Yeah, so there's some stuff that we might need or want to clean up. Oh, is it crossing over here? Yeah, it's probably crossing over here, vref. Yeah, it's probably trying to get around this trace. So we would need to go through here. That's stupid. Yeah, okay, get it. I get it. Okay, so it was really hard to get there. With 6-layer, EMC will be more happy. Yeah, I know. Yeah, you're probably right. So adding an additional ground planes on top and bottom, and then having one additional signal layer and putting everything. So basically the stack up would be signal, ground, power, signal, ground, signal, something like that, with 6 layers. We could do that. So basically have the ground coupled directly there in the second layer. Yeah, this is worth thinking over, that we could go to 6 layers for these boards. I need to get a quote from King Credit to know what pricing I am looking at and what the price difference is, and if I want to pay the penalty of 6 layers versus 4 layers. The other thing that is probably doable is, I think the via sizes here, there are 6 threes, so they could be 5 threes in theory. So we could gain some more routing freedom here. Oh, there are 2 different ones. There you go. So that's probably a 5-3. Yeah, this is a 5-3, and these are 6 threes. Yeah, that's fine. If we have the space for it, then why not make the annular ring bigger? All right, so let's go back and try to let's finish these up. So Timon, thank you for your follow. You decided that it is worth it finally, huh? Just kidding. Thank you so much for your follow. Just trying to be mean to the people that I know. So there we go. So that's that. They're pretty much staying in their original position. Yeah, that's true. But in this case, it is pretty much done. It's like this board is mostly laid out, and there's only some quirkiness, like some uncleanliness because of the 4-layer versus 6-layer thing. It's like we could clean up a few signals here and there to make it more smooth, but it's really a good question. Is it worth it or not worth it? If I was starting with the design now to speed up things and get to the result faster, it might be worth just starting with 6-layer and just being like, okay, I blast through this layout and not worry with... so there is a trade-off there. But on the other hand, it's like if you want to optimize it for 4 layers, it might be worth it. So it's, as with every engineering project, it's a hard trade-off thing, which like Jared talked to. Oh, it's oh, it's your Prime subscription. Thank you so much. Thank you so much, guys. Let's see. Yeah, thank you for the follow, Jared. I appreciate it. Now I can be mean to you, huh? Now that you followed me. Yeah, if you are doing a really high quantity and you are trying to squeeze the every cent out of a project, then again it is worth spending more time on the design. Oh my God, Jared! I did the sides of you that I didn't know. That's great. Yeah, so I also figured out that I am learning about Twitch. Yeah, subscribed. Hey, Shaggy. Thank you for the Prime subscription. So yeah. What's going on here? There we go. Let's try doing this. Can one of the moderators take care of it? Thank you. I'm not sure how. I think there's... Where is the... Oh, there's the users in chat. I think, did I make Jared? Sure, brained. How do I do this? Just wait. And then Timon. Sorry, folks. Lethal, you are also a common viewer here. You're also a mod now. Whoever else, it's like I think we have now a few more mods. Sorry about that. You're also a mod. Okay, added a few of you. By the way, my little experience, sometimes the problem isn't the number of layers, instead the impact of pad and vias on that. Sometimes it is more useful adding blind and buried vias instead of layers for same amount of money. Very, very good point. Yep, Jared is drunk with power. See him rage. It's like so out of character. If you knew Jared in person, it's like you would know why I'm laughing so hard. All right. Yeah, there you go. So that's a very good point, Mr. Menela. So I did have that. I actually had a design where I added a single set of blind vias. That was cheaper to solve and make the layout easier than adding additional layers. That was an interesting experience. Yeah, that's a very good point. We have here the typical dog bone escape for the FPGA, because that works out in this size. But via and pad, there is always very often a good reason to add blind vias to this. Also, the price differs depending on if you have blind vias or buried in blind vias. It's like how many sets of vias you have. That changes the pricing more often than not. So yeah, it's an interesting puzzle always. So yeah. Let me move this. Yeah, the V6. So the biggest problem, I think, with the pad... SpreadQ, thank you for the follow. Welcome to the stream. So yeah, the stack up issue that got brought up, I think... George Locamides, there you go. Brain sometimes really melts. Anyway, so George, he also, because he comes from the Altium side of things, he was submitting a lot of things. He's working very closely with some of the KiCad developers at the moment because of the Open Ventilator project. So he was submitting a bunch of feature requests to KiCad, and a bunch of this stuff will be addressed in v6. So that is very nice. I'm looking forward to that. And yeah, the one thing with the via stackup is the ability to say on which that if a via goes through multiple layers, that the layers in between, they don't need pads if they are not connected to anything. So they basically just make pads on top and bottom and plate through the whole instead of adding pads on the intermediate layers. So this is something you can save space and route next to just a hole. So you only have a distance from the hole and not the distance from the hole and the pad that you have to take care of. So this is something that KiCad currently doesn't support, and will be a good addition when it does. So yeah, I'm looking forward to that, because I do want to get into more complex PCB designs soon. So this will be very interesting to have. So this footprint, for example, this should go, we can make, oh, I don't want to, no. Don't untangle this. How do we do this? How do we do this? So I think I have to reroute this, go around, unless we can get this one out, because this via has to go here, and we have to go from the top, and this one goes here, and this one will go between the pads. So let's move this out of the way. So this is actually, this KiCad is the updated version. They had a release this last week. Yes, it does. Nightly has rounded corner routing. It is still very much work in progress. It is not really ready for prime time yet, but it is there, which is very exciting. So it's imminent in a way that we will be getting that functionality in KiCad, which is very exciting. Clock ref. So the best thing would be to actually escape it here between the pads. But then we have to move all this stuff around here. That's not really happening. Yeah, there's the tools for manipulating rounded corner traces. They need to be expanded. They need to have more controls where you can just adjust the radius more and stuff like that. It's there's a lot of details. I'm very excited to see them there already. So it means this will be pushed pretty hard, pretty quickly. Alright, so let's see. Yeah, so this maybe we can do this easier. So first of all, we can move this for sure. We can connect these. So that should be easy. So that's done. And now we should be able to go to page down. Up. Let's do this way. So now I should be able to move this one. Let's move this via here. Like this. I hope this is working. We can edit this and then slash. Where's slash? What's going on? Oh, there. Good. There we go. And now we are connected. So that's sorted. And then and done. And done. So that's good. Let's give it a little bit more space here. There's no need to be squishy about this. Okay, so the top resistors are done. Can do these in a minute. Let's try to sort out this puzzle here. Well, first of all, we want to... This will be interesting. Yeah, this will be fun too, because we have to clean all this up. Oh, come on. Don't be nasty to me. Don't be nasty. All right. It's trying to speak up. All right. And then there we go. There we go. There we go. These are easy because they just need to be repositioned. And these are easy too. And the question will start. I'm trying to procrastinate as much as I can here before I actually address the interesting part. So this is the interesting part. How do we cross these? Because we have this trace that goes from the top here and then goes all the way down to the sink. So this is essentially sink. And the one solution would be to do a TMON and put it on the power layer, and then we can route this inside. The other one would be to somehow swap it with vias on here, and that's a good question how to do that. So now this move of putting on a power layer has officially the name TMON. Well, yeah, theoretically, but I don't want to do it to white quark. I would like this version of the hardware to be exactly electrically compatible with the revC1. I don't want to screw things up here. It's just adding additional complexity to the software. It is possible, we could do that, but I don't feel... Although there is also another possibility. We can swap them physically here. So we can put these in opposite positions. I don't know what it does to the direction selection lines. It shouldn't do much. It just goes, this one will go first and the other one will go second. So that should do it. Okay, Timon, I get it. I'm just pulling your leg. Don't worry about it. Yeah. I get it. I know how you meant it. Just being facetious, or whatever the correct word is here. Can I change the lanes? I can't really, so I would have to swap this to this side and then move all dB0. Yeah, well, it's not, I don't see it as easily as what you're saying. Oh, you mean, huh. U3. This one would have to go this way. And the DB0, how do you want to escape it? I would have to move U4 to here, U3 to here, DB0 to here, and then break out the via on the right side. That would work. Yep, that would work. DB7, then DB6, then DB0. Again, DB760, 760. 760, yeah. And then I have to move the U4 and U3 to the right side for the dog bone. So that would work. Come on. Why? Come on. I know you can do this. Why is it... That's an U4? Why is it U4? Now suddenly. Oh, is there something on the internal layer? Wait. Oh yeah, there is. That's the problem here. Yep. That's why I would have to... This like impacts a lot of stuff. 1.2 volts. Can I get it the other way, some other way around out? Not really. U5. It's not being cranky, it was correct. It was correct. It was complaining at me for good reasons. Yeah. Let's try it. Fine, I will try it. Up, escape. U5, a tighter, so basically go closer like this, and you think it will be enough to pass the via? I'm not sure about that. Yeah, I can't move this via, so let's see. First of all, we have to go to finer grid. There, and then yeah, I don't see this happening. This is still not enough for the via to come here. Oh, go all around, like this way. Yeah, that would work. And then I have these, and basically pass between these pads. Okay, yes, good point. And let's try that. Let's remove this first. Let's move this guy. Come on. Why are you being a jerk? There. So, space. Come on, delete, track, delete. Track, delete, there we go. There we go. So that should do this, and then we can move this one. This is weird why it is like doing such a weird thing. I know it should work. Yeah, it's just very weird. And then we will have to route this on the inner layer. Come on. There we go. There we go. There we go. Okay, so let's do this. And then we can go on the U5. Oh, ha 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 ha. You can't get between vias. I have to go like all around here. Oh, that's stupid. There we go. Come on. So much dirt. But yeah. All right, so let's do this. All right, so now that we did this, we can swap these. This goes down here, so swap. This one will swap to the other side. Let's just delete this for now, and we can move this one. There we go. And then we can move this one. Come on. Let's go back to the bigger grid. Like this. Probably like this to make more space. There we go. And now we should be able to do this. I have to be careful here. I think I have to be tighter. I still have to make more space here. This via is a problem. Let's do this. Like that. It's not that it is really a problem. I can make it straight here. Something like that. Let's just figure out if we can get past here and how much space we have to make. Ah, perfect, perfect. It's working, it's working, it's working, it's working, it's working. Very good. Good job. Poor bias. Yeah. There we go. So that worked. Thank you for the suggestion. I was being skeptical for no reason. I'm happy when I'm wrong in this way. Will this work? There we go. Nice and straight. And we sorted out this mess. This trace is now crazy. The U5 is nuts. Yeah. Oh my god, this goes like all around. Where is it going, U5? Oh, it's just an LED. It's fine. Oh god. Yeah. Let's see. How does this inner layer actually look like? The net. Could I just go... Let's regenerate this. It's being sliced anyways. Who are you, actually? Oh, it's 3.3 volts. And the 3.3 volts is connected from here. So in theory, we could make a longer one and untangle it. But is it worth it? Probably not. Oh, it's another 3.3 here. So we probably shouldn't do that. And definitely we shouldn't cut it off here. That's a bad idea. I think we should leave it the way it is. Yeah, it's like KiCad has a lot of interesting ways of handling. Oh my god, this is bad. What's going on here? You are very close to this pad, but you are ground, right? Anyways, yeah, KiCad has a lot of very interesting features that we don't think about, and it's like being able to handle stuff. Yeah. I'm not sure how I figured it out. I think I was just poking around at it until it's like, oh, maybe I might have read it somewhere that there's a grab button. This is fine. So the DRC settings for ground pads are interesting. So or not ground. It's in general, if you have a signal, the same. Oh, come on. Just. There. Now you have a kink. Now you should have. And now you're going all around it to straighten it out. Should I just let you? Maybe I should just let you do this. And I can move this guy out. Because then 3v3 is connected over the top here. Yeah, if the via or the signal is the same as the signal, it doesn't complain, the DRC. So yeah. That's all I wanted to say. I think that's... Yeah, I probably could. I probably could move all this stuff here. I want to keep a ink there. I probably could squeeze it in there. Oh, I don't... Do I feel like yak shaving that one? Probably not. That's the problem. I think I'm lazy here. dB0. What I can do is move this one definitely like this. That's definitely doable. So yeah, there you go. That's cleaner for sure. Yeah, I could probably move stuff around and put the U5 near the dB0 somewhere here and move all these traces to the side. Yeah, definitely. PCB layout in general should come with an OCD warning for sure. Yeah, that's why I said it's like you never are done with a PCB layout. You are only close enough. That's what it is. So let's figure out another puzzle here. So this one has to get through here. Oh my goodness. There's not enough space here. But I can put it just here, the DB7. It does not need to be there. It's not as clean, but it works. And then I can do this. I want to enter like this. Thank you. DB2. It's probably even better option, yeah. DB2. Here. Well, I still would have to like drag this, like extend. I already extended this. I'm already cutting through the 3v3 plane around, so it is like has to go all around. Okay, let's just keep doing this. Aw, dude. Seriously? That's not pretty. I know you like hugs, but please don't. Social distancing in traces, please. There we go. Okay. Yeah, it's hugging again. Stop hugging. This is an algorithm that does basically it's meant to do that. This is on purpose. It's meant to hug outsides of pads. There was an issue before where it was not doing that and caused other problems. I'm pretty sure this is on purpose. Okie dokes. And now this one. Nope. There we go. Oh, come on, come on, come on, come on, come on. That's better. There we go. Yeah, see, that's just, I think this is, what? No. This is the hugging algorithm there. Hugging the pads. We don't need to be so constrained here. Can do this, that's cleaner. Yeah, the track posture is always wrong. It's always the wrong way around somehow. But slash is your friend. Hi there, Zigors. And then vSense. Can I just move the vSense out of the way here? Yeah, we don't need to have it obstruct us here. Make this nice and straight-ish. Straighter. There we go. Very nice. There we go. There we go. There we go. Let's keep it even to the other traces. There we go. That's looking okay, I think. Yeah, I think I can choose. Well, at least I can choose if it is push and shove or whatever. So there is, if I'm in B and then right click and then edit. So interactive, so I have the highlight collisions is another one, then shove is another one, and walk around is another one. So yeah, you can switch between them. I could have highlight collisions, for example, so that would be an option. That looks different like this, so it shows what it collides with. And then it is not trying to optimize the route of others. So yeah, that's probably faster in this particular case. Sometimes, yeah, it's like, but at least how I remember Eagle, that was quite a while since I used it, is like the fully manual mode. It's I think the highlight collisions one is pretty much that. So I think the highlight collisions has the advantage that it is actually showing you the collisions instead of preventing you from routing over it. Yeah, okay, whatever. So I'm sure it is different now. Because they also, I think, added, like, shortly after KiCad got the push and shove router and Autodesk took over Eagle, they were like, let's add features like crazy, and one of them was the push and shove router, as far as I remember. And everyone was like, oh, great. Yeah. There we go. So how do I print boards? You generate Gerber files and order them from the PCB vendor of your choosing. So that's what I do. Yeah. Yeah, instead of having / having the right click. I think the problem in KiCad is that the right click menu has a lot of functionality, and having the router take it over might cause issues. But yeah, there's a point to be made about this, sure. But I don't think like the / is not really a problem. Let's see. Yeah, on a normal keyboard, because I'm using Dvorak, so for me it is a little bit weird. But on a normal keyboard, you just press / to do the posture change. So it's not really that big of a deal, in my opinion. So yeah, it's like now you see it's actually not an issue. Yes, I hear you. So that's good. And then we can do this, and we can do, well, this one is fine. This one is all right. Can just maybe do this like this. So that's clean. Yeah, the slash is the posture change. I don't have the keyboard indicator like showing which keys I'm pressing enabled, because someone on the last stream complained that the marquee was too distracting, and Spima didn't come around yet to add the other rendering options to the visualizer, so I'm only having the mouse key indicator, so left click, right click, and then like the modifiers. So the keyboard thing will come back in the future, but at the moment I will have to call it out which key it is if you are curious about which key does those functions, some of the functions. That will be interesting again. So we have to put this via up here again. So let's do this first to procrastinate a little bit and not have to deal with the hard stuff. This should be good. Can we get that done or not? Do I want to do this? Not sure. Let's leave it like this for now. All right. As I said, this stream is pretty much a chill stream where I'm doing just a bunch of PCB layout, mostly. And not the most exciting one, except we had some exciting stuff. We had the having to sort out the escape from the BGA. That was, I found, pretty exciting. Uh, 2004. Would you recommend 2004 for the Open FPGA toolchain? Wait a second. So what is what? 2004, I don't even know what it is referring to exactly. Yeah, I don't know El Viejo. El Viejo Andy. That's a good name. So I am using on one of my laptops, I have updated to Ubuntu, the 2004. It works fine. It's like you just have the toolchain. So the precompiled toolchain binaries, they are statically linked, so it doesn't matter. They should work. I have not tested them myself yet, but Eddie probably will know. But otherwise, if you compile it yourself, it's not a problem. So yeah, Jared is also using the open tools on 2004. So yeah, there's nothing to say against using 2004 for the open tools. Okie dokes. Now we can yeah, my local build tools. Yeah, you have to rebuild them. So you have to recompile them. But yeah, I recompiled them and they worked fine. Let's do this. Okie dokes. Spider. I still don't remember exactly. I think these are meant to that you can put your own pull-up resistor values in here. So if you want to decrease the pull-up pull-downs, there are 10K resistors here in the pull-up pull-down, but you can have a pin header here and then put in wired resistors in here in parallel to decrease the pull-up pull-down resistance, so to pull harder. It's a nice feature. So yeah, maybe we should populate actually these connectors. That would be useful. All right, I need a very short break and I'll be right back. So don't go anywhere. I just need a second. Where is the... There we go. There we go. I'm back. Sorry about that. What's going on here? Yeah, thank you. Yeah, alrighty. Oh, interesting. Now that I look at this, we could actually have these resistors vertically here. Like this. And then go in there and then go outside. Maybe this will be quite choky if we do that. Yeah, anyways, I think the easiest thing is to move this I/O power trace out of the way and then move this guy. How did I do this? Here? Oh, interesting. So it is going from the back one. Let's get it out of the way first. So this is just power. Interesting. So this is not signal. Not signal. Interesting. So I can put it just here. That would work. And then connect it to here. Yes. So I can just put it back where it was. And instead of connecting to here, I can connect it to there. It's not as equal as it was before, but it will do the job, right? So I think, what is it, 3.5 or something? It's 4.5, Jesus, that's a chunker. What is this trace? It says 2.5. 2.5. Page down and connect. So that will work. And then I can do this. Then I have enough space to route this. All right. This is not 2.5. This is probably 2. Oh, it's 1.5. Okay, 1.5. Like this. Very good. Come on. I want this to go like that. There we go. We can move. Yeah, we want the kink in there. I want the traces to come out of the pads at one side. It's I'm not sure that matters very much, but this is like a gut feeling regarding like thermal, in like how the pads heat up and cool down in reflow. It's like I have the feeling this might make things a little bit more evenly flow. There we go. Yeah, I think that's better. Like this. Come on. I wanted to move you here. There we go. Like this, and then like this, and then like this. Very nice. This one also should be moved so that it gets the kink out properly. And then here, and then kink out and kink out. There we go. That's cleaner. And we can this, yeah, we did the same thing with there we go. I think this is how that would work. And then we can do this. Yeah, I'm aligning these corners here with the courtyard, at least roughly, make it look somewhat even. Okie dokie, so now we can do this. Like that. There we go. Oop, we are too close. Too close. This one is too close too. So this one is too close too. Oh my goodness. So I have to move this. There we go. That will be there. Then I can move this one like this. Oh, we will have to. Right, we have to clean these up. Now that I think about this. Because these are the new chips. So we will have to clean up all the connections to all these here. Because they don't seem like they are in the way, but they are. That might explain why it was behaving so weird before. Yeah. It will be interesting. So yeah, we have to clean up that that whole area of the level shifters. Doesn't seem like it, but it needs some help. Oh, we have another rainy day today here. It's very soothing in my opinion. That's nice. Plants are thanking us for some rain for once. Do I want it this way? It should be good. I don't like the acid trap in there. Let's do this way. I think that's cleaner. Yeah, we should just escape. Then the corners here are not so sharp. Yeah, there we go. Let's do this. And you're still unhappy, right? Right. Then we go this way, this way, this way. Oh, come on. Come on, my friend. There we go. There we go. Yeah, we have to clean these up. This will be like this. Oh man. It's finish these because I have to clean up all this stuff here. That will be fun. But yeah, we are pretty much laid out again. We could make an experiment like this is. Yeah, sure. It's possible that it's an urban legend about the acid traps. That's how I call the sharp corners anyways. Yeah, fair enough. There we go. That's nice. This one is still unhappy. Let's do this. There we go. That should do it. Then I should be able. There we go. Now it's clean. Come on. Oh, this one is colliding again. I'm sure that's why it is preventing me. Yep, there we go. Same thing, same thing. There we go. Let's do this. Let's do that. Let's delete this. Let's delete this. There we go. So now this will work. Bam and bam. All right. That seems to be working. Okay, so how many do we still? Yeah, we have 0 unrouted, so at least it is routed, so that's good. It's just auto-routed and be done with it. Yeah, that's right. I don't care how it looks as long as it works, yes. But when it looks good, it works well too. That's what I tell myself. So that I can sleep. Yeah. Yeah, so one thing we could experiment with, it's like, you remember my rant about USB-C? What about if we put USB-C on here? That could be interesting. I think in this particular case, do it. Yeah. So, so the advantage of in this particular case, this PCB is quite large. So the likelihood of getting enough leverage to cause trouble with the connector is higher. Yeah, I'm glad it worked out. Yeah. People are very excited about USB-C. I'm not that excited about this as some others, but it's yeah. Someone already did that. Like 2 people already did that in their own versions. I might do that. Put USB-C on here. It won't add too much of complexity. We already have BGAs and QFNs and whatnot on the board. And I think having a heavier duty, higher cycle count connector might be an advantage, like especially the solder tabs. It shouldn't be an issue here with the micro USB, but it might. So maybe we should give USB-C a chance here. You even broke some routing rules. Yeah. So if we put USB-C connector on here, so that's let's just at least investigate how it looks like. Connector, USB. And USB-C, we need the one that is, oh god, which one is which? There's several of them. So I want the one that doesn't have so only the USB 2.0 one, so not the complex one with like double row. So you can have, this is how a full USB-C connector looks like, or even worse, you have like mixed, yeah, something like that. That's a pretty nightmarish connector, like half through hole, half not through hole. So I already have some from LCSC that I got. But anyway, so this is pretty much. So let's see. I have them here, I think. Somewhere in here. Ah, this is this? No. I thought I threw them in here. I really thought I threw them in here. Anyways, I have some of them already. Well, I can't find them at the moment. Maybe they are somewhere else. But anyways, I have some of the USB-C connectors, but essentially they have a footprint like this with just locating pins and those pads. So let's see how that compares. So this is, I think, so I need to make more space in here. So that definitely is the case. Unless I put this like that and let it protrude. USB-DM. USB-DM? What? Oh yeah. So yeah, there's let's see. So let me show you what Jared sent there. Wrong browser. This browser. There we go. Let me move this over here. Congratulations. I wanted to have another tab there. So yeah, that's what Jared sent over. There's just a few vias that you need to do that, and then you need to like swap the direction and stuff. Yeah, for 2.0 it is not that complicated. The connector, so this is the interesting thing to keep in mind here. If I use a certain connector here, it might be worth it to go with a USB 3.0 supporting connector. Yes, I'm not using super speed at the moment, but if I'm already using a connector, it might be worth going with a 3.0 and 3.1 like super speed supporting connector, so that when I get to that and I use those on other projects, I can increase the quantity of the same connector I'm using. So yeah, that might be worth it. So I'm not sure. But I think for this project, I think the quantities of the Glasgow will be in a realm where we can just stick with this. Also, I'm using... Are they though, Timon? They are like, if I wanted to go for cheap, I would go with the micro USB connector. They're definitely cheaper. So it's like the USB-C connectors are not cheaper than a micro USB connector. Well, also not 2 cents. It's like the USB-C connectors from LCSC are more expensive than the micro USB genuine ones from FCI that I'm getting. So it's not like I am buying cheap or crappy 2 cent USB micro USB connectors that are junk. I'm buying actually pretty good ones, and they are still cheaper than the USB-C connectors from LCSC. So there you go. It's not like the USB-C connector is cheaper. Yeah, they are 20 cents, and I'm paying like 15 or whatever. So for good connectors. And so so it's like the argument about the pricing is not one I would use for USB-C versus USB micro. So that's a bad argument there. And there might be other advantages of using that. And it's like, in my opinion, it might be robustness. Also, it is the up and coming. Yeah, how often will you be plugging in the Glasgow here? Also, I have connectors that again, don't come at me with like reliability of micro USB connectors, because I use them a lot since many years, so I know how reliable micro USB connectors are. If you're not buying garbage, they are pretty reliable and they work very well, especially on small boards like this. So it's not true that they are not reliable. Yeah, so again, Act 2, yes, so USB-C, yeah, it's not, yeah, maybe it is sturdy or whatever. Anyways, So the board is larger on this, and so maybe USB-C is a slightly better solution. So it is definitely not for price. It will definitely be more expensive using USB-C connector, no matter what we do. But it's the price difference is not huge, obviously. So it's not really a problem. The bigger problem is this. This is what I don't like about USB-C. It's like, do you see the pin pitch? Reworking this is definitely harder. At least it's one row, so that's good. But it's still more pins, finer pitch, harder to rework. It's the micro USB connector has less pins, has coarser pitch. It's easier to rework. It's more reliable from the manufacturing standpoint, 100%. So this is the advantage of micro USB here. Also, I have a lot of experience with the micro USB, so it's like I know where the edge cases are and problems are. The USB-C is also larger and needs more PCB space, so we will have to figure that out. Well, I talked with Arturo about this. I will not be convinced by Arturo in this case. Anyways, I know the advantages, disadvantages. It's just I might use that as a possibility to explore this. Yeah. So if I don't need USB 3.0, the advantage of USB-C here is, like, as Timon says, it's slightly more reliable. It's like if I probably should go with at least with the USB, micro USB that has the tabs in it, so that it solders into the board, because the Glasgow is a larger board. So getting enough leverage to, like, rip it off is easier probably, even though you have to essentially put your foot on this thing and rip the cable vertically up to rip it off. People do that because people are really rough with their hardware, but it's like, in general, I just be nice to your hardware. You paid money for it. Even if you didn't, it is technology that should be used and cherished and not treated like garbage. So don't be rough with your hardware. That's it. Same thing. It's like phones. Like, how many screens did you break? It's like, stop breaking screens. What are you doing? Why? This is something I still don't get. Like, people like dropping stuff and throwing stuff around and being very uncareful with their things. Anyways, I might do the USB-C thing. I am not 100% convinced yet. If it might be a good experiment here to actually see how hard the USB-C stuff is, especially because on the Glasgow we have a little bit more. It is a more expensive board, so the price differences are not as feelable, and it might be a worthwhile experiment to do that here. I will leave that here for maybe next stream. I might do an experiment and splice it in between streams or something, but no promises yet, but we might go that way. I don't think they do it on purpose, but you're probably right. It's like, but just, ham-fisted. Yeah, maybe. I don't know. It's just, from several people that I've seen, they're very, they don't appreciate the stuff they have. This is what I have a problem with. It's like, if you are just clumsy, well, you probably can't do much about that. But if you are just rough with stuff because I don't have time for this, let me just blast through it. that's not the right attitude. I don't like that attitude. There is a lot of energy and a lot of effort that went into things, and the fact that it was, even if it was cheap, it's like be rough with it. Why? All right, so we still have to clean up the stuff here. So we will. There's not much space here. This one, probably I should just route it on the inside, shouldn't I? Yeah. There we go. That does it. Then I can move this one away. Let's see if that. So I would want this to be on the center line. Can I even do that? I don't think I can. Yeah. There we go. Yeah, I will have to move all the VIOBs up and then VDBs up and clean this up here. And it doesn't go all the way up, but it goes. There we go. And then this is 2.5. There we go. That's nice. Now it is hugging nicely. So much cleanup here. This is what usually you don't see. It's like half of the layout is just going through with a fine-tooth comb to clean up some garbage like this. It's like all of this stuff because I changed those footprints. So I changed all these footprints to the bigger footprint. So now I have to clean up all those traces. But yeah. Not for DB1 between pads 3. I probably could. Wait, what? DB1 between pads 3 and 4. 3 and 4, like going down here? Yeah, I could. Yeah, true, that cleanup. Yeah, this will be a full afternoon of me just tinkering and poking at things and cleaning this up. Yeah, I'm not sure. I still have to look at the bottom. There might be a better scheme for routing this, that we can keep it nice and symmetric, because it would be nice to keep some cleanliness on this. So have a nice clean layout on here. Right. Yeah, can we? Yeah, we probably don't need more traces in here. So we have those capacitors. Oh, they were closer by. Because, oh, I can move them out now because these are bigger, so they can be moved. The problem is, oh, this is another moment where I think of George Locamides. So he says, it is better to have power go through the pad and then to the target pad and not have it in between. Can we make that happen? But then we need two vias. That is nasty. I don't like that, because then we need a via that goes in on this side and then goes to the other side to this pad. Yeah, no, we are not doing that. That's too much via. Although we have the space for it, right? We do have the space. We can just move these here and then have the vias come in on one end, go through the capacitor, go through the other side, and then connect to the pad. So we could do that. I might experiment with this. But anyways, I think we are at the 2-hour mark of our stream, and I will cut it off here. Let's see how much I will get done until next week, until Tuesday. Hopefully we will have something finished, or closer to finish. Maybe I can order some prototypes of this board. If you have, besides the USB-C thing, if you have some other suggestions what we should do, there was some suggestion to change the voltage regulators. I would like to keep these. The DFN packages have better dissipation, and it's I know already with the SOT23s, they have higher thermal resistance, so these can actually dissipate power a bit easier into the board with the ground pad and whatnot. So I would like to keep these. This is something I wanted to upgrade to on my other projects anyways. So even though they are harder to get than SOT23s, I like this solution better. From power standpoint, especially this board is drawing quite a lot of power if you are using all the I/O and you have all this stuff running, and also you have this additional power supplies here for the outputs. Well, they are not being driven from here, so they are just for the logic. So yeah, I like those. Otherwise, yeah, let me think. Yeah, I think that would be it. I will clean up this section and sleep over the USB-C thing a little bit more, but I think you all are so excited about this that we might give it a shot, actually. And otherwise we have everything else pretty much there. So let's see at our to-do list. That's the good point. So we are almost done with that point, and we will have to yeah. So yeah, a better stencil. Well, it's not like as in stencil printer is a factor, but a bigger factor is the design of the stencil itself. That is the hard part. It's like getting what the pad shrink should be or expansion, depending, tweaking that usually is the magic there. Stencil printer, yes, it gives you more consistency for sure. Glasgow's I will be contracting out for assembly, for the main assembly, not for prototypes. So I think this should be fine. The biggest problem now is because I'm contracting it out, I need to have the Pogo pin tester fully functional. So that's a big stall to get that done. So I should probably place an order for that. I just use the default one at Osh Stencils. So I use the Osh stencils. I will show you what I mean with that. So this is where I order my stencils. I stopped using the Chinese ones because I just get warped and weird shit from them. So I get them from here. And I think they have a default thickness, and I use that usually. Yeah, so the assembly, the biggest problem with the Glasgow is it has so many BOM lines that it is pretty much at the limit of my pick and place machine. And I just have this gut feeling that the Glasgow crowdfunding campaign might require a quantity where it doesn't make sense for me to assemble them. So my pick and place machine, I have the feeling it will take at least half an hour per panel, if not longer, to assemble one panel. And that will be just, it will be hard to produce any significant amount of them. So I really have to make sure that I'm doing everything I can so I can make assembly at a contractor. The prototypes, I still probably will make batches of 10, 15 or whatever of prototypes, but they are hybrid assembly. So I do the placements that require a lot of placements on the pick and place machine, and oddball like single parts or whatever I do manually. So that's fine. Yeah, that's for sure. Fully manual assembly takes a long time. But for this, it still takes a few hours to assemble the Glasgows, even with making the pick and place machine place. The back side is fully machine placed on my prototypes, and on the front side, everything down to parts that have 5 or more placements are placed also in the pick and place machine, and the rest I place by hand, so that I don't have to set up the whole machine and all the feeders, and because that takes hours and hours and hours and hours. So it only makes sense if I do a significant amount of them, and then like the trade-off between the speed of my pick and place machine and the assembly becomes a problem. So yeah. Oh, you have a go-to? Oh yeah, Timon, for sure. Let me know. Yeah, I know who I want my PCBs from already, so that's pretty clear. But CM for assembly, I might just go with the default one that KiCad is using, because they already have an established relationship with them. Just to simplify the path, but it might have an advantage of having someone that one can rely on reliability and assembly quality and testing and whatever. But yeah, until next week, I will try to put together the Pogo Pin tester requirement so I can send it out for quote. So that we can get that ball rolling, and I hopefully will have a more finalized version of the Glasgow ready so that we can get the prototypes rolling. Yeah, we will see, depending on how the rest of the week happens. And yeah, otherwise, as per usual, thank you very much everyone who is supporting this. It's like all this work going into the hardware and going into these streams. It wouldn't happen without you being here in the chat and people supporting all of what I'm doing. The Twitch subscriptions are very valuable. Thank you very much. The people that get stuff from 1BitSquared, thank you so much for your support. And if you want to support what I'm doing, always the Patreon link is below. I really appreciate that, and thank you so much for your support. And I would like to give, as per usual, a shout out to a few individuals that are wonderful, generous Patreons of this stream. So thank you very much to Aki Van Ness, Brennan Ashton, Drew Fustini, Edward Borden, Go Jimmy Pie, Jeff Wang, Jordi Paki Rodriguez, Kelly, Matthias Pritchett, Miha Benovets, Sean C, and Tom Keddy. So thank you very much. Yeah, as always, if you have been, thank you for watching. Bye.